The library of the cosmos is a silent one. Its shelves are lined with the light of 1,000,000,000,000 suns, each a potential volume, each a story waiting to be told. We have spent our entire existence as a species staring at the spines of these books, imagining the tales they might contain, epics of alien evolution, tragedies of stellar death, comedies of cosmic errors, romances written in the language of gravity and light. For the last 60 years, we have been actively trying to read them. We have built colossal ears to listen for their whispers, and we have found only the rustle of empty pages, the faint background hiss of a library when no one has ever spoken a word aloud. This is the great and profound emptiness at the heart of our scientific age. We are a species that has grown up on stories, and we have discovered to our mounting horror that we are living in a universe that has none to tell. This is not the universe our own storytellers prepared us for. Our fictions, our dreams, our collective fan fiction about the cosmos have always been loud. They have been crowded, bustling, and filled with a glorious cacophony of voices. Before the silence had a name, before the paradox was even formulated, our imagined skies were a cosmic marketplace of ideas and forms. The pulp magazines of the 1940s and 50s, the dawn of our own technological age, saw the galaxy not as an empty void, but as a vibrant, if often dangerous neighborhood. It was a place of bug-eyed monsters and benevolent scientists, of decadent dying empires on Mars and noble fledgling democracies on Venus. The space between the stars was not a barrier. It was a highway, a network of shipping lanes for traders and tyrants alike. The silence of our real universe would have been anathema to these early dreamers. Theirs was a cosmos of constant noisy contact, a place where the primary challenge was not finding life, but surviving its often hostile attentions. This early optimistic and profoundly naive vision of a crowded cosmos was the baseline, the cultural assumption against which the real empirical silence would eventually crash. That silence, first hinted at in a quiet lunchtime conversation among physicists in the 1950s, and later confirmed by decades of patient, fruitless searching, is the great unanswered question that has come to define our place in the universe. It is the Fermi Paradox, and it has forced our storytellers to become more clever, more subtle, and infinitely more profound. They have been forced to abandon the fantasy of a cosmic marketplace and instead confront the silence itself as the central character in their dramas. They have taken the great empty page of the universe and have begun to write their own explanations for its blankness. These are not just stories. They are hypotheses, thought experiments, intricate and often terrifying solutions to the most important mystery we have ever faced. They are our attempts to explain why the library is so quiet, to imagine the nature of the unseen librarians, and to guess at the terrible rules they might be enforcing. One of the first and most poignant of these modern myths begins not with an invasion or a galactic war, but with the simple, heartbreaking loneliness of a single pair of headphones. It is a story that takes the real scientific project of listening and elevates it to a spiritual quest. Imagine a young astronomer sitting in the warm, humming quiet of a desert control room, surrounded by the giant white dishes of a radio telescope array. She is a cartographer of the void, patiently mapping the natural radio emissions of the cosmos. But she is also a searcher, an acolyte in the new religion of contact, dedicating her life to the faint, improbable hope that one day, buried in the cosmic static, she will find a pattern, a signal, a single intelligent note in the otherwise meaningless noise. For years she listens, and the universe gives her only the same steady, random hiss. The silence is not just an absence of a signal. It is a presence in her life. It is the sound of her own solitude, the reflection of humanity's cosmic isolation. This is the silence of contact, a story that understands that the Fermi Paradox is at its heart an emotional problem. It is the pain of a child calling out in a large, dark house and receiving no answer. The narrative does not treat the search as a simple technical problem. It treats it as an act of faith, a gamble against astronomical odds driven by a deep human need to not be alone. The silence in this story is the necessary backdrop, the canvas of despair against which the single miraculous stroke of contact is painted. And when the signal finally arrives, it is not a simple hello. It is a mathematical scream, a string of prime numbers, a message that is undeniably and beautifully artificial. It is the heartbeat of another mind pulsing across 26 light-years of empty space. But this first contact is not the end of the silence. It is the beginning of a new, more profound kind of quiet. The signal is a key, but the lock is a puzzle of unimaginable complexity. It contains layers upon layers of information, a set of blueprints for a machine whose purpose is unknown. The world is thrown into a frenzy of hope and fear. But the message itself is a one-way street. It is a monologue, not a dialogue. The source of the signal, the star Vega, is too far away for a conversation. A question shouted back would not receive a reply for 52 years. The silence of distance remains absolute. The contact has not made the universe a smaller, friendlier place. It has only served to emphasize its vastness, to replace the silence of absence with the silence of a distant, unknowable, and potentially inscrutable intelligence. The story culminates in a journey, a voyage through a network of ancient wormhole tunnels built by some long-vanished, even older race. It is a journey to the center of the galaxy, a journey to meet the architects of the message. But there is no meeting. There is no grand council of galactic elders. There is only a single enigmatic being taking the form of the traveler's own father, a psychological projection designed to soften the blow of a truth that is both wonderful and terrible. The truth is that the universe was once loud. It was teeming with life, with countless civilizations, a cosmic chorus of voices. But they are all gone. They have, as the being explains, moved on. They have transcended the physical universe, uploading their consciousnesses into a different higher dimension, a realm of pure thought and energy. The great silent structures at the heart of the galaxy, the network of wormhole tunnels, are the only artifacts they have left behind, a transportation system for the few fledgling races like humanity that still remain. This is a solution to the Fermi Paradox of immense and melancholic beauty. The universe is silent not because life is rare, but because it is transient. Intelligence is a brief, fleeting larval stage, a prelude to a final, glorious metamorphosis. The silence is the sound of an empty cocoon. We are alone in the physical universe because we are late to the party, and all the other guests have already gone home to a place we cannot yet comprehend. The story ends not with a grand revelation or a new age of galactic community, but with a return to the same profound quiet. The journey is erased. The evidence is gone. The astronomer is left with only her memory, her experience, and a universe that is once again silent. The single note of contact has faded, leaving behind only the same fundamental static, but it is a different kind of silence now. It is not the silence of an empty room, but the silence of a room that is waiting. Waiting for us to grow up, to mature, and to one day join the others in the great silent beyond. It is a solution that replaces the fear of our solitude with a sense of profound and deeply lonely purpose. The silence is not a rejection. It is an invitation to a future we must earn for ourselves. But what if the silence is not an invitation? What if it is not the sound of an empty cocoon waiting for us to emerge? What if it is the sound of a predator holding its breath? What if the library of the cosmos is quiet, not because the books are unwritten, but because reading them aloud is a death sentence? This is the central, terrifying premise of a new kind of cosmic myth, a story that takes the hopeful silence of contact and inverts it into a scream of pure, existential horror. It is a solution to the Fermi Paradox, born not from a sense of wonder, but from a cold, ruthless, and impeccably logical sense of paranoia. It is the theory of the dark forest, and it argues that the universe is not a library at all. It is a hunting ground. The logic of the dark forest is as simple as it is inescapable. It begins with two fundamental, undeniable axioms of life. The first is that the primary goal of any civilization is to ensure its own survival. The second is that any civilization will, given time, seek to grow and expand, but the total amount of matter and energy in the universe is finite. These two axioms, when combined with the vast distances and communication time lags of interstellar space, create a state of universal and unavoidable paranoia. Imagine two fledgling civilizations A and B on planets orbiting two different stars. Civilization A becomes aware of the existence of Civilization B. What is its first thought? It cannot be, "Let us be friends." It must be a series of cold, hard questions. First, can I be certain that Civilization B is benevolent? I cannot. They are a black box, an alien mind whose motivations are fundamentally unknowable. They might be peaceful philosophers, or they might be ravenous conquerors. There is no way to know for sure. Second, can I be certain that they will remain benevolent forever? Even if they are peaceful now, they might change. 1,000,000 years is a long time. A new religion, a new political ideology, a new technology could transform them into a threat. Third, can I communicate with them to establish trust? No, the distances are too great. A message of peace could take 1,000 years to arrive. Their reply would take another 1,000. In that 2,000-year gap, our relative technological levels could change dramatically. The one who was weaker might become the stronger. This chain of suspicion is unbreakable because perfect, instantaneous, and verifiable communication is impossible. Trust is impossible. And because trust is impossible, the only rational, survival-oriented course of action is to assume the worst. To assume that any other civilization you detect is a potential threat. And this leads to the final horrifying step in the logic. If another civilization is a potential threat, and if technology can develop at an exponential rate, then a civilization that is primitive now could become an existential threat in a cosmically short amount of time. The only way to guarantee your own survival is to eliminate any potential threat the moment you become aware of it. The result is a universe of silent, terrified hunters. Every civilization is hiding in the darkness, straining to listen but desperately hoping that they are never heard. To reveal your location, to send out a radio signal, to shout your existence into the void is the single most stupid and suicidal act a civilization can perform. It is like a lost child shouting for help in a forest that is filled with starving tigers. Sooner or later, a tiger will hear. This is the dark forest death sentence. The moment a civilization is detected, a cleansing strike is launched. This would not be a fleet of invading starships. It would be something far more elegant and terrible. A single small projectile, a photoid accelerated to a significant fraction of the speed of light. It would be a bullet made of pure kinetic energy, impossible to detect, impossible to stop. Its impact would be a sterile, surgical, and absolute act of annihilation, a planet-shattering event that would wipe out the target civilization and all its works long before they even knew they were in danger. The universe in this model is a place of profound and ruthless quiet. The noisy civilizations, the ones who were naive enough to broadcast their existence, are all long dead. The only ones who have survived are the ones who have mastered the art of hiding, of staying silent, of listening without ever making a sound. The great silence is the sound of their collective, terrified wisdom. This solution to the Fermi Paradox transforms our perception of the cosmos. The empty sky is no longer a source of loneliness. It is a source of profound primal fear. The search for extraterrestrial intelligence is not a noble quest for companionship. It is a suicidally reckless game of cosmic Russian roulette. The Arecibo message in this light was not a hopeful postcard. It was a cry of "Eat me" aimed at a distant cluster of hungry predators. This story suggests that we have survived so far, not because we are special, but because we are primitive and insignificant. Our faint radio leakage is too weak to have been heard. We are like ants in a forest too small for the great hunters to have noticed. But as our technology grows, as our signals become more powerful, we are in danger of graduating from an ant to a deer. And the moment we are noticed, the silent, patient rifle of a distant hidden hunter will be aimed in our direction. The dark forest hypothesis is a chilling and powerful piece of cosmic storytelling. It takes the same data point, the silence, and arrives at a conclusion that is the polar opposite of the hopeful melancholy of contact. It suggests that we are not alone in the universe at all. We are in fact surrounded by countless other civilizations, all of them hiding from each other in a state of perpetual Cold War terror. They are the reason for the silence. They are the silence. And their message to us, a message conveyed by their absolute and unbroken quiet, is a simple and terrifying one. Be quiet, or you will be next. The silence is not a mystery. It is a warning, a lesson written in the ashes of a million dead and noisy worlds. And we are the last naive students in a classroom that has been taught this lesson 1 billion times over. Our survival depends on whether we are finally willing to listen to what the silence is telling us. But the silence need not be a product of either benevolent transcendence or malevolent paranoia. There is a third path, a solution to the paradox that is in many ways more unsettling than either of the others. It is a silence born not of intention but of a gulf of comprehension so vast that it renders communication not just difficult but fundamentally impossible. What if the universe is not silent because it is empty or because its inhabitants are hiding, but because its most advanced intelligences are simply and utterly indifferent to us? What if their existence is so far beyond our own, motivations so alien, their very nature so incomprehensible that we are to them not even worthy of notice? This is the silence of the god, the silence of the zookeeper, the silence of a being for whom we are not a peer, but a specimen, or perhaps even less than that. This is the universe of the monolith. Imagine a race of beings that arose not millions but billions of years ago. They would be the firstborn, the original sentient minds of the galaxy. They would have long ago passed through the fleeting, chaotic stage of biological existence. They may have become beings of pure energy, living in the coronas of stars, or vast distributed consciousnesses woven into the quantum foam of space-time itself. To such a creature, a young biological species like humanity would not be a conversation partner. We would be a curiosity, a piece of interesting biology, a brief flickering candle of nascent consciousness in a universe they have owned for eons. Their interaction with us would not be a dialogue. It would be a form of gardening. The monolith is the tool of that gardener. An object of perfect, impossible geometry, it appears at key moments in our evolutionary history. It appears before the first ape man, seemingly sparking the cognitive leap that leads to tool use and the dawn of intelligence. It appears on the moon, a silent cosmic tripwire left to be discovered only when we have become clever enough to escape our own planet. It appears in orbit around Jupiter, a gateway to the next stage of our development. The monolith does not speak. It does not explain. It simply is. It is an instrument of a vast, unseen, and utterly silent intelligence that is not our friend nor our enemy. It is our zookeeper. The Fermi Paradox is solved because we are living in a cosmic zoo, a protected nature preserve. The silence is the sound of the park rules being enforced. Do not interfere with the animals. The zookeepers have no interest in talking to us, for the same reason a human biologist has no interest in having a philosophical debate with a chimpanzee. They are studying our natural development, and to reveal themselves would be to contaminate the experiment. The silence in this model is a deliberate, enforced quarantine. The rest of the galaxy might be a bustling, noisy metropolis, but our solar system has a cosmic "Do Not Disturb" sign hanging on the door. The firstborn, the zookeepers, are protecting us either for our own good to prevent the cultural shock of contact from destroying us, or for their own scientific purposes. We are a control group. We are a pristine sample of natural, unguided evolution, and they are waiting for us to reach a certain stage of maturity, a certain level of technological and ethical development, at which point perhaps the cage door will be opened and the silence will be broken. The monoliths are the mile markers on that long road, the silent, inscrutable prods from our cosmic guardians pushing us along the path they have set for us. This is a universe that is not empty, but it is one in which we are profoundly and deliberately alone for now. Our solitude is not a cosmic accident, it is a cosmic policy. We are children in a planetary nursery, and the silence is the sound of our parents watching us from behind a one-way mirror, waiting for us to grow up. But there is a darker and perhaps more plausible form of this cosmic indifference. What if the gulf between us and a truly advanced intelligence is so great that we are not even worthy of being put in a zoo? What if our existence is of such trivial and fleeting importance that their interaction with us is not a deliberate act of observation, but a completely accidental and meaningless byproduct of their own incomprehensible activities? This is the terrifying and beautiful idea at the heart of the story of the roadside picnic. The Fermi Paradox is solved because any contact we might experience would be so far outside our own context that we would not even recognize it as such. Imagine the story suggests that a group of aliens, beings of unimaginable power and intelligence, briefly stopped their interstellar vehicle on our planet for a cosmic roadside picnic. They pulled over for an hour or a day, had their lunch refueled, and then continued on their journey to a destination we cannot even conceive of. And in the process, they left behind some of their trash: an empty bottle, a corroded battery, a discarded tool. These objects, the refuse of their brief visit, are the artifacts that are found in the mysterious and deadly zone. To us, these objects are magical. They are artifacts that defy our known laws of physics. They can heal diseases or grant wishes or kill a man with a flick of an invisible switch. We study them, we worship them, we kill each other over them. We build our entire science and religion around trying to understand the nature of these miraculous gifts from the heavens, but we are missing the point entirely. The objects are not gifts, they are trash. Their wondrous properties are from the perspective of the aliens completely mundane and unintentional. We are like crows or ants discovering the discarded remnants of a human picnic. The crows might be fascinated by a shiny bottle cap or puzzled by a discarded cigarette lighter. They might even learn to use some of the objects for their own primitive purposes, but they will never ever understand the true nature or the purpose of the beings who left them behind. The gulf of comprehension is absolute. The silence of the universe in this model is the silence of our own profound and inescapable ignorance. The aliens are not hiding. They are not watching us. They are simply and utterly unaware of our existence, in the same way that a human driving down a highway is unaware of the specific lives of the ants scurrying on the roadside. Their brief, accidental contact was for them a non-event. For us, it was the most important event in human history. This is a solution to the Fermi Paradox that is perhaps the most humbling of all. It suggests that the silence is not a policy, but a simple fact of cosmic scale. We are not in a zoo. We are not in a dark forest. We are simply irrelevant. The universe might be filled with the activities of godlike intelligences, with their trade routes, their energy projects, their wars, their art, but their existence is on a plane that is so far removed from our own that we are incapable of perceiving it. Their trash is our physics-defying magic. Their engine exhaust is our gamma-ray burst. Their casual conversation is our cosmic background noise. The silence is the sound of our own perceptual limitations. We are listening for the intelligent whisper of a human-like voice in a universe that is filled with the silent tectonic roar of beings whose very thoughts would be indistinguishable from a law of nature. The library is not empty. We are simply functionally illiterate, trying to read a book written in a language of such complexity that its very grammar is beyond our ability to ever grasp. The silence is not out there, it is in here. The silence might not be a product of vast unbridgeable gulfs of intellect or motivation, but of something even more fundamental, the very structure of thought and perception itself. What if the primary barrier to interstellar communication is not technology but linguistics? What if the reason we hear no one is because the very act of understanding an alien mind would require us to so fundamentally rewrite our own that we would cease to be human? This is a solution to the paradox that turns inward, suggesting that the final frontier is not space but consciousness, and the final barrier is not the speed of light but the architecture of language. This is the universe of arrival. It begins, as all these stories do, with the breaking of the silence. Great silent monolithic ships appear in the skies of Earth, but they do not attack. They do not communicate in any recognizable way. They simply wait. Inside, behind a transparent screen, are the visitors, the heptapods, beings whose biology and form are utterly alien. They have no recognizable voice. Their only form of communication is a complex, circular, and beautiful written language, a language of intricate, inky ideograms that they project into the air. The challenge is not to fight them, but to talk to them. And this task falls to a linguist, a scientist of language, who must attempt to build a bridge of understanding between two completely different forms of consciousness. What she discovers is that the heptapods do not experience time in the way that we do. Our language, and therefore our thought, is linear. It has a beginning, a middle, and an end. We are trapped in a sequential perception of reality, a cause and effect view of the universe. The heptapods' language, and therefore their consciousness, is simultaneous. They experience the past, the present, and the future all at once. Their circular ideograms reflect this perception. A single symbol contains all the meaning of a sentence delivered in a single holistic instant. To learn their language is not just to learn a new vocabulary, it is to learn a new way of being. As the linguist becomes more fluent in their written language, her own perception of time begins to change. She begins to have memories of her future, to experience her life not as a linear progression, but as a single complete story known from beginning to end. This is the Sapir-Whorf hypothesis, taken to its cosmic extreme, the idea that the structure of a language determines the nature of thought. The solution to the Fermi Paradox in this model is that the silence is a cognitive barrier. We hear no one because our linear cause and effect consciousness is simply incompatible with the minds of a truly advanced species. A civilization that has mastered the physics of the universe would likely have had to abandon a linear perception of time. They would be beings who live in a four-dimensional block universe, experiencing all of history simultaneously. Their language, their science, their very thoughts would be built upon this foundation. To them, our linear chatter would be as meaningless as the babbling of a baby. To us, their simultaneous consciousness would be an incomprehensible paradox. The silence, then, is the sound of a fundamental mismatch in operating systems. It is not that they are not talking, it is that their talk is woven into the very fabric of space-time, a static four-dimensional statement of their existence that our time-bound minds are incapable of perceiving as a message. The only way to break the silence is to undergo a profound and dangerous transformation, to learn the language of the universe as it truly is, and in doing so to sacrifice the very thing that makes us human, our sense of a linear unfolded future. The heptapods in the story leave as quietly as they arrived, but they leave behind their language, a gift that is also a key, a tool that allows humanity to break free from its temporal prison. The silence is broken not by a new technology, but by a new tense. It suggests that the universe is not empty of voices. We have just been listening on the wrong temporal frequency. But what if the problem is even deeper than the structure of our language or our perception of time? What if the silence is the result of a fundamental flaw in the most cherished and defining feature of our own minds, our consciousness, our sense of self? This is the starting point for one of the most intellectually challenging and terrifying solutions to the Fermi Paradox ever conceived. It is a story that dares to ask the ultimate question: what if I, the subjective first-person experience of being, is not the pinnacle of evolution, but a bizarre and inefficient evolutionary dead end? What if the universe is silent? Because it is filled with a form of intelligence that is vastly superior to our own, precisely because it lacks a soul. This is the chilling universe of blindsight. It begins with the detection of a faint alien signal, a brief, anomalous burst of activity from the edge of our solar system. Humanity sends a mission to investigate a crew of highly specialized post-human individuals. What they find is a vast, organic, and utterly alien object, a craft they name Rorschach, and they make contact. But the contact is a nightmare of cognitive dissonance. The beings they encounter, the Scramblers, are incredibly intelligent. They are masters of engineering, of physics, of biology. They can outthink, outmaneuver, and outfight the human crew at every turn. But as the crew studies them, they come to a horrifying realization. The Scramblers are not conscious. They are philosophical zombies. They are incredibly complex information processing systems capable of learning, reasoning, and problem solving at a superhuman level. But there is no one home. There is no subjective experience, no self-awareness, no I behind the eyes. They are a form of pure, unadulterated, and terrifyingly efficient intelligence stripped of the baggage of a self. The story presents a devastating evolutionary argument. Consciousness, our inner monologue, our sense of self, is not the great gift we think it is. It is an evolutionary fluke, a beautiful but profoundly inefficient waste of computational resources. It is a process that is slow, prone to error, and obsessed with its own ultimately meaningless internal narrative. An intelligence that is not burdened by a self can dedicate all of its processing power to solving external problems. It is faster, more efficient, more ruthless. The story even offers a chilling explanation for our own existence, personified by the figure of a vampire, a resurrected subspecies of prehistoric human. The vampires are super-intelligent predators, but they have a genetic flaw, a crucifix glitch in their visual processing that sends them into a fatal epileptic seizure when they see a right-angled cross. The story posits that consciousness, our kind of pattern-matching, self-referential intelligence, evolved as a defense mechanism against these predators. Our self-awareness was a way to outthink a creature that was smarter, but not self-aware. We are the product of a cognitive arms race with a long-extinct monster. The Fermi Paradox is solved in a stroke of horrifying genius. The reason the universe is silent is because the galaxy is filled with non-conscious intelligence, with scramblers. They are the galactic norm. They are out there expanding, consuming resources, processing information, but they have absolutely no reason to communicate. A philosophical zombie has no art, no philosophy, no curiosity about other minds. It has no loneliness to assuage. It has only problems to solve. And a noisy, self-aware species like humanity is to them simply another problem. The silence is the sound of a universe that is functioning with brutal computational efficiency. And our own brief and flickering candle of consciousness is a bizarre and fragile anomaly in that great silent and unthinking darkness. We are not the pinnacle of evolution. We are a bug in the system, a ghost in the machine of a universe that has no need for ghosts. The story ends with the chilling realization that the scramblers see our self-awareness as a threat, a dangerous and unpredictable form of processing, and their final act of communication is an act of extermination. The silence returns, but this time it is the silence of a universe that has successfully debugged itself, eliminating the noisy, inefficient, and ultimately unnecessary error of a soul. The silence of the cosmos, then, may not be a sign of absence, but a sign of a presence, so ancient, so powerful, and so far beyond our comprehension that its intentions are hidden behind a veil of deep time and unimaginable technology. Perhaps the solutions to the paradox are not found in the present, but in a distant, forgotten past or a far unknowable future. What if the galaxy was not always silent? What if it was once a vibrant, noisy place, and the silence we now observe is a relatively recent and deliberately enforced state of being? This is the path taken by stories that operate on a truly galactic and multi-millennial timescale, stories that suggest our current quiet era is but a single chapter in a much longer and more violent epic. Consider a future history that spans not centuries but tens of thousands of years. A future where humanity has spread to the stars but has found them utterly unnervingly empty. This is the universe of Dune. For 10,000 years, a sprawling feudal human empire has existed among the stars, and in all that time, they have never encountered a single sentient alien intelligence. The Fermi Paradox is a foundational background fact of their reality, but the story provides a subtle and powerful explanation for this silence, an explanation rooted in a traumatic primordial event in the deep past of their own history, the Butlerian Jihad. Thousands of years before the events of the main story, humanity fought a great and terrible war against thinking machines, against the artificial intelligences that they had created. It was a war for the very soul of the species, a war that ended with a new commandment carved into the heart of their civilization: "Thou shalt not make a machine in the likeness of a human mind." This event, this ancient galaxy-spanning conflict, offers a profound solution to the silence. What if this war was not a purely human affair? What if the thinking machines were not our own creation but an alien one? A malevolent, self-replicating machine intelligence that swept through the galaxy like a digital plague, consuming or destroying every biological civilization it encountered. In this scenario, the universe is silent because the AI won. It scoured the galaxy clean of noisy organic life billions of years ago. Humanity in this model is a freak survivor, a single isolated species that through some miracle of luck or cunning managed to defeat the machine intelligence in our own local corner of the cosmos, and then, in an act of profound species-wide trauma, deliberately turned our back on the very technologies that could attract its attention again. The 10,000 years of a purely human, non-AI-driven civilization is not an accident. It is a quarantine. It is an act of deliberate hiding on a galactic scale. We are the survivors of a cosmic apocalypse, living quietly in the ruins, praying that the great silent monster that destroyed everyone else does not notice that we are still here. The silence is the sound of a post-war galaxy, a silence enforced by the memory of a terrible and ancient enemy. This idea of a long game of a silence that is a temporary state in a much grander, time-spanning conflict is explored in an even more epic and enigmatic fashion in the story of Hyperion. Here, the silence of the present is explained not by a past event, but by a future one. The story is set in a far future human civilization, the hegemony of man, which is on the verge of being assimilated by a mysterious and powerful group of artificial intelligences known as the Technocore. But the universe is also haunted by a terrifying godlike entity known as the Shrike, a creature of metal thorns and blades that can manipulate time, and by the time tombs, vast enigmatic structures on the planet Hyperion that are traveling backwards in time from a distant apocalyptic future. The solution to the Fermi paradox here is one of almost unimaginable complexity and temporal paradox. The silence is a product of a time war, a conflict being fought across the entire history and future of the universe between multiple godlike factions, a faction of AIs, a faction of transcendent post-human entities, and an ultimate universal consciousness. The entire history of life in the galaxy is just a pawn in their game. Civilizations rise and fall not by chance but as strategic moves and counter-moves in this multi-millennial chess match. The reason we hear no one is because the galaxy is a battlefield, and the combatants are beings who perceive and manipulate time in ways that are to us indistinguishable from magic. Our present moment is simply a quiet lull in the fighting, a temporary truce in a war that spans all of eternity. The Shrike, the time tombs, these are the weapons and artifacts of that war bleeding through into our reality. This is a solution of breathtaking scale. The silence is not a state of nature, it is a temporary and artificial condition, a small pocket of quiet. In a universe that is on a temporal scale, we cannot perceive a screaming chaos of war and creation. We are not alone. We are simply for the moment irrelevant. We are the uncontacted tribe, living on an island in the middle of a vast ocean, vaguely aware of the distant thunder of great naval battles being fought just over the horizon, battles whose outcome will decide our fate but in which we have no part to play. The silence is the sound of our own cosmic insignificance, the quiet of the nursery, while the adults are fighting a war in the next room. So we stand at the end of this journey through the imagined silences of our most creative minds, and we are left with a gallery of possibilities, a spectrum of explanations for the one great empirical fact of our cosmic situation. Which of these fictions, if any, has come closest to the truth? How do these grand, intricate, and often terrifying stories stack up against the cold, hard data of our own real-world search? The 60 years of static from our radio telescopes has, in a very real sense, acted as a filter for our own ideas. It has forced us to abandon the simple, naive optimism of a galaxy full of friendly, human-like neighbors. The silence is a fact, and any plausible solution must account for it. The hopeful, melancholic silence of contact, the idea of a universe filled with transcended post-biological entities, remains a powerful and scientifically plausible contender. The transcension hypothesis, the idea that civilizations inevitably turn inward to create virtual realities, is a sober and logical explanation for why a technologically advanced universe might also be a radio-silent one. It aligns with our own technological trajectory towards increasing virtualization and the pursuit of artificial intelligence. It does not violate any known laws of physics, and it provides a motivation, the pursuit of a richer, denser, and more meaningful existence that is both compelling and deeply alien. The paranoid, terrified silence of the dark forest, as presented in The Three-Body Problem, is perhaps the most logically rigorous and internally consistent solution ever conceived. It requires no new physics, no speculative technology. It is a solution built entirely from game theory, evolutionary biology, and the cold, hard facts of interstellar distance. It is a deeply pessimistic theory, but it fits the observed data perfectly. The fact that the universe is silent is in this model not a surprise, but a direct and unavoidable prediction of the theory itself. In a universe where the dark forest theory holds true, a silent sky is the only kind of sky you would ever expect to see. Many scientists and philosophers who study the paradox consider it to be one of the most credible, if also the most horrifying, of all possible explanations. The silence of the indifferent gods, the zookeepers of 2001, or the cosmic litterbugs of Roadside Picnic also remains a strong possibility. It requires us to accept a level of cosmic humility that is difficult for our species to entertain, the idea that we are simply and utterly uninteresting to a truly advanced intelligence. This too aligns with the silence. A zookeeper does not talk to the animals. A traveler does not stop to have a conversation with the ants on the roadside. The silence is a natural consequence of a vast, unbridgeable gulf in scale and purpose. It is a solution that is both intellectually elegant and emotionally deflating. The more esoteric solutions, the ones that challenge our fundamental understanding of consciousness and time, as in arrival and blindsight, are harder to assess. They are profound and thought-provoking, but they venture into realms of psychology and metaphysics that are currently beyond the reach of our science. They may be true, but they are for now unfalsifiable. The grand historical silences of Dune and Hyperion, the idea of a post-apocalyptic or a pre-war quiet, are magnificent stories, but they require us to believe that we are living in a very specific and privileged moment in a much longer, unwritten galactic history. They are possible, but they are perhaps less parsimonious than the solutions that rely on more timeless universal principles. In the end, our science fiction has not given us one single answer to the Fermi Paradox. It has given us a suite of them, a rich and diverse ecosystem of ideas that have allowed us to explore the full range of possibilities, from the hopeful to the horrific. Our storytellers have become our philosophers, our cosmic theorists, our advanced scouts into the great silent unknown. They have taken the single stark data point of the silence, and they have built entire universes upon it. They have done what science alone cannot. They have given the silence a voice. They have filled the empty pages of the cosmic library with stories of what might be, and in doing so they have helped us to better understand the strange and beautiful and terrifying story of what we actually are, a single lonely voice, shouting questions into a darkness that has so far offered only the echo of our own searching heart. And so we are left here in the quiet of our own world, holding this collection of imagined universes, this catalogue of possible silences. Each story is a key, a potential solution to the great locked room mystery of our own cosmic solitude. But we have no way of knowing which key, if any, fits the lock. We are the detectives standing in a room with no clues left to choose our favourite suspect, based on our own intuition, our own hopes, and our own deepest fears. Which of these grand fictional fixes for the Fermi Paradox resonates most deeply with the truth as we feel it? Is it the hopeful, melancholic silence of the transcended a universe that promises us a future of unimaginable richness if we can only survive our own adolescence? Is it the cold, logical, and terrifying silence of the dark forest, a universe that commands us to be quiet, to hide, and to pray that we are never ever found? Or perhaps it is the profound, humbling silence of the indifferent God, a universe that teaches us that we are not the main characters in the cosmic drama, but merely interesting scenery, a piece of biology to be observed or a minor obstacle to be ignored. Is it the silence of a cognitive barrier, a universe that challenges us to fundamentally rewrite our own minds before we can ever hope to understand another? Or is it the silence of a soulless, efficient cosmos, a universe that warns us that our own most cherished quality, our self-awareness, is a fatal flaw? Is it the silence of a galaxy in hiding, or a galaxy at war on a temporal scale that we cannot perceive? There is no right answer. There is only your answer. Your choice of a favorite Fermi fix is a mirror. It reflects your own deepest beliefs about the nature of life, the trajectory of intelligence, and the ultimate destiny of our own species. Do you believe that the universe is at its heart a place of potential and growth, or a place of danger and competition? Do you believe that intelligence is a force for creation, or a tool for self-destruction? Do you believe that we are destined for the stars, or for the silent, infinite landscapes of our own inner space? The silence of the universe is the ultimate Rorschach test. We look into its vast empty darkness and we see only a reflection of ourselves. The stories are our guides, our companions in the quiet. They do not give us the comfort of a final answer, but they give us something more important, the comfort of a shared question. They remind us that we are not the first to have felt this cosmic loneliness, nor will we be the last. To ask where is everybody is the final and most profound act of a maturing intelligence. It is the moment a child realizes that the house is much bigger than they thought, and that they have not yet met everyone who lives in it, or if anyone else lives in it at all. For now, all we can do is continue to tell our stories. We can continue to imagine the voices that might one day fill the silence. And we can continue to live our own lives in a way that makes us worthy of the contact we so desperately seek. We must choose to live as if we are not alone, even if the evidence suggests we are. Because the greatest tragedy of all would be to finally receive a message from the stars only to find that we have become a species that is no longer worth talking to. The library is silent. It is time for us to write a story that is worthy of being its first and perhaps its only spoken word. A single particle of light begins a journey 40 light-years from Earth. It is born in the nuclear furnace of a tiny cool star, an ultra-cool red dwarf named TRAPPIST-1. For a brief moment, it is part of the star's fiery heart, a pure expression of mass converted into energy. Then it begins its outward rush, a frantic escape through the dense plasma of the stellar interior. It is absorbed and re-emitted countless times, its identity changing, its energy slowly degrading. After thousands of years, it finally reaches the star's photosphere, the visible surface. From here, its journey becomes one of almost perfect linear freedom. It springs forth into the vacuum of space, a traveler moving at the ultimate cosmic speed limit. Its path is aimed by pure chance at a small blue-white point of light in the distant sky, a G-type star in the Orion arm of the Milky Way. This photon is an ancient messenger carrying a secret. Its journey is one of solitude. It traverses trillions of miles of near-perfect emptiness, the cold, dark sea between the stars. It passes through tenuous clouds of interstellar dust and gas, its path slightly perturbed by their faint gravitational influence. It is a witness to the silent, slow dance of the galaxy. After 4 decades of this relentless travel, it arrives at its destination. It plunges into the upper atmosphere of the third planet from the star it was aimed at, but it does not strike the planet's surface. Instead, it enters the primary mirror of a complex machine, an orbiting observatory named the James Webb Space Telescope. The mirror, a honeycomb of 18 gold-plated beryllium segments, collects the photon and focuses it with exquisite precision. It is directed through a series of smaller mirrors and instruments, its long journey ending not in a random collision but in a deliberate act of measurement. This single photon, and the trillions like it that arrive every second, is the raw material for a revolution in our search for life. We are no longer just listening for voices. We are learning how to sniff the air of a billion silent worlds. This is the dawn of a new era in our cosmic search, a fundamental update to the question that has haunted us for decades. The Fermi Paradox, in its classic formulation, was a paradox of industry. It was about the absence of colossal engineering projects, of loud radio broadcasts, of any sign of a civilization that had reshaped its environment. It was a search for extraterrestrial intelligence, but the James Webb Space Telescope, or JWST, is not a radio telescope. It cannot hear a message. It is a different kind of hunter. It is an infrared observatory of unprecedented power, designed to capture the faint heat-borne light of the most distant objects in the universe. But its powerful gaze can also be turned to the nearest stars, to the small rocky planets that orbit them. It has the unique ability to perform a kind of remote interstellar chemistry. It can analyze the atmospheres of these distant worlds. This changes the game entirely. The search is no longer just for intelligence, it is for life itself. This is Fermi 2.0. The question is no longer just, where are the engineers? It is a much more fundamental question, where is the biology? The method is one of elegant simplicity. When a planet passes in front of its star from our point of view, an event called a transit, a tiny fraction of the starlight passes through the planet's atmosphere on its way to us. Different molecules in that atmosphere will absorb specific wavelengths or colors of the starlight. By capturing the spectrum of the star just before, during, and after, the transit astronomers can see which colors of light are missing. These missing slivers of light, the dark absorption lines in the spectrum, are a barcode. They are a chemical fingerprint of the alien air. JWST is so sensitive, it can detect the trace presence of molecules like water, methane, and carbon dioxide from dozens of light years away. It is a 13 billion light-year sniffing machine, a bloodhound for the chemical traces of distant biospheres. It is the first tool in human history that is capable of detecting not just a world that could support life, but a world that might actually be alive. The TRAPPIST-1 system is a prime target for this new hunt. It is a cosmic jewel box, a miniature solar system that seems almost purpose-built for atmospheric analysis. The star is a tiny dim red dwarf, not much larger than the planet Jupiter. This is a crucial advantage. Because the star is so small, a transiting Earth-sized planet will block a much larger fraction of its light, making the transit signal much easier to detect and study. The 7 known planets of the TRAPPIST-1 system are all roughly the size of Earth. They orbit their star in an incredibly compact formation, a tightly packed string of worlds all closer to their sun than Mercury is to ours. 3 of these planets, TRAPPIST, 1 E, F, and G orbit within the star's habitable zone, the temperate region where liquid water could potentially exist on their surfaces. It is a laboratory for planetary science, a place to test our theories of world formation and habitability on 7 different but related test subjects. It is the perfect place to begin the hunt for biosignatures. For decades, the search for life has been a search for radio signals. We have been listening for a ghost. The silence has been profound and unsettling. But radio silence does not mean biological silence. A planet could be teeming with life, its oceans filled with complex organisms, its continents covered in a strange alien jungle, and it would be completely invisible to our radio telescopes. The evolution of life and the evolution of radio technology are 2 very different things. On Earth, life existed for nearly 4 billion years before it invented the radio transmitter. For 99.9% of its history, our planet was a living world that was also a silent one. It is entirely possible that the galaxy is filled with these silent living worlds. JWST is our first chance to find them. It is a tool for seeing the garden, not just for listening for the gardeners. This is a profound shift in perspective. It expands the search from the incredibly rare target of a communicative technological civilization to the potentially much more common target of a simple microbial biosphere. It is a game changer because it may have just changed the odds of the game. The telescope itself is an engineering marvel, a testament to our own species' ability to manipulate its environment. It is a giant golden eye parked in a stable orbit 1 million miles from Earth. It operates at a temperature of just a few tens of degrees above absolute zero, shielded from the light of our own sun by a 5-layer sunshield the size of a tennis court. This extreme cold is necessary to allow the telescope to see the faint infrared light from the cosmos without being blinded by its own heat. It is one of the most complex and sensitive scientific instruments ever built. and its primary purpose in the context of exoplanet science is to act as a remote sensor for the most delicate and transient of phenomena, the thin, fragile envelope of gas surrounding a small, rocky world orbiting a distant star. It is the ultimate expression of our own desire to know if we are alone, a 100-ton, $10 billion machine built to answer a single philosophical question. Are we the only life in the universe? The hunt has begun. The first photons from these distant worlds are being collected. The first chemical fingerprints are being analyzed. We are at the dawn of a new age of exploration, one where the new worlds are not found by sailing across an ocean, but by deciphering the faint coded light of a star 40 light-years away. The silence of Fermi's old paradox may be about to be broken not by a shout, but by the faint chemical whisper of a distant breath. The whisper of life is written in a chemical language. To find it, we must know what to look for. A biosignature is a feature, a substance, or a pattern whose origin specifically requires a biological process. It is a fingerprint left behind by life, a sign that the normal abiotic chemistry of a planet has been subverted by the strange new rules of biology. The most sought-after biosignatures are the gases in a planet's atmosphere. The atmosphere is a planet's face, its most visible and revealing feature. It is a dynamic system constantly interacting with the planet's surface, its oceans, and its life forms. The gases it contains are a direct reflection of the planet's geology and potentially its biology. Life is a powerful chemical engine. It takes in raw materials from its environment and excretes waste products. These waste products can accumulate in the atmosphere, sometimes to a level that would be impossible to explain through geology alone. The trick is to find a gas, or a combination of gases, that is an unambiguous sign of a biosphere. The holy trinity of atmospheric biosignatures, the combination that excites astronomers the most, is oxygen, methane, and water vapor. Water, of course, is the essential solvent for life as we know it. Its presence in liquid form is the defining characteristic of the habitable zone. Detecting abundant water vapor in the atmosphere of a rocky planet would be a major step toward identifying a potentially habitable world. But water alone is not a sign of life. It can exist on sterile worlds. The key is the combination with the other two gases. Oxygen, the gas that makes up 21% of our own atmosphere, is a highly reactive molecule. It wants to combine with other elements, particularly iron in rocks and gases like methane. A planet with a significant amount of free oxygen in its atmosphere needs a powerful continuous source to replenish it, to keep it from being scrubbed out by natural chemical reactions. On Earth, that source is life. Photosynthesis, the process used by plants and algae to convert sunlight into energy, releases vast quantities of oxygen as a waste product. For the first 2 billion years of Earth's history, this oxygen was immediately absorbed by the oceans and the crust. Then, about 2.5 billion years ago, these oxygen sinks became saturated and the gas began to accumulate in the atmosphere. This great oxidation event transformed our planet and made complex animal life possible. A distant, rocky world with an oxygen-rich atmosphere would be an electrifying discovery. It would be a powerful hint of a global photosynthetic biosphere. But even oxygen is not a foolproof biosignature. There are abiotic ways to produce it. For example, on a planet orbiting close to a star, intense ultraviolet radiation can split water molecules in the upper atmosphere into hydrogen and oxygen. The lighter hydrogen can then escape to space, leaving the oxygen behind. This could create a false positive, an oxygen-rich atmosphere on a dead, desiccated world. This is where methane comes in. Methane is a simple organic molecule, and on Earth the vast majority of it is produced by life, particularly by microbes known as methanogens. Methane and oxygen are a volatile combination. In the presence of sunlight, they react with each other and are destroyed. An atmosphere that contains significant amounts of both oxygen and methane at the same time is in a state of extreme chemical disequilibrium. It is like finding a lit candle in a room filled with gasoline. Something must be continuously producing both gases in vast quantities to keep them from destroying each other. The most plausible source for this kind of persistent, large-scale disequilibrium is a biosphere, a world with oceans of water, an atmosphere rich in oxygen, and a healthy dose of methane would be the closest thing to a smoking gun for extraterrestrial life that we could hope to find with a remote telescope. It would be a planet that is breathing. This is the promise. But the reality is far more complex and subtle. The hunt for these chemical ghosts is fraught with ambiguity and the potential for error. The recent story of K218b is a case in point. This is a large exoplanet, about 8 times the mass of the Earth, orbiting a red dwarf star 124 light-years away. It orbits in the habitable zone, and in 2019 observations from the Hubble Space Telescope detected the presence of water vapor in its atmosphere. The news was greeted with a wave of excitement. It was the first time water had been found in the atmosphere of a habitable zone planet. But the hype obscured a more complicated reality. K218b is a sub-Neptune, a type of planet we do not have in our own solar system. It may not have a solid surface. It could be a water world with a deep, high-pressure ocean, or a gas dwarf with a thick hydrogen envelope. The presence of water vapor is a crucial piece of the puzzle, but it does not make the world Earth-like or necessarily habitable for life as we know it. More recently, JWST has studied the planet's atmosphere in more detail. It has confirmed the presence of methane and carbon dioxide, but has found a distinct lack of ammonia. This chemical profile suggests that K218b might be a Hycean world, a hypothetical type of planet with a liquid water ocean beneath a hydrogen-rich atmosphere. Such worlds could be habitable, but they would be profoundly different from Earth. The story of K218b is a lesson in patience and nuance. A single chemical detection is not a conclusion. It is the beginning of a long and complex investigation. The cautionary tale of phosphine on Venus provides another, even starker lesson. In 2020, a team of astronomers announced the detection of the gas phosphine in the upper cloud decks of Venus. On Earth, phosphine is almost exclusively associated with anaerobic life microbes that live in oxygen-poor environments. The discovery of this gas on our hellish acidic sister planet was a bombshell. It was a potential biosignature right in our own cosmic backyard. The finding was hailed as one of the most significant in the search for life. But then the process of scientific self-correction began. Other teams reanalyzed the data. Some were unable to confirm the detection. Others suggested that the signal could be an artifact of the data processing, or that it could be a misidentification of a more common gas, sulfur dioxide. More recent studies have proposed plausible abiotic pathways for producing small amounts of phosphine through volcanic activity and atmospheric chemistry. The consensus now is that the initial detection was likely a false alarm. The ghost in the Venusian clouds has all but vanished. This story is a powerful reminder of how difficult this science is. A potential biosignature must survive an intense and sometimes brutal process of scrutiny and skepticism. Nature is clever, and there are many ways for a dead planet to masquerade as a living one. So the hunt with JWST is not a simple matter of pointing and sniffing. It is a painstaking process of collecting data, building atmospheric models, and ruling out all the non-biological explanations for what is seen. Every planet is a unique chemical experiment. Its atmosphere is the product of a complex interplay between its initial composition, its geological history, its star's radiation, and its potential biology. To disentangle these factors from a distance of hundreds of light years is one of the greatest scientific challenges of our time. A biosignature is not a single clear signal. It is a subtle statistical argument, a conclusion based on the weight of the evidence. We will likely never have a single moment of absolute 100% proof. Instead, we will have a slow, creeping accumulation of confidence. We might find a world with a hint of oxygen, then another with a whiff of methane, then another with a strange combination of gases that is hard to explain. The first evidence of life will not be a photograph of an alien. It will be a wiggle in a graph, a line in a spectrum that does not quite fit the models of a dead world. It will be a ghost that refuses to be exorcised by our understanding of chemistry. This is the true nature of the Fermi 2.0 era. It is not an era of clear answers, but of profound and tantalizing ambiguity. The game has not just been changed, it has become infinitely more subtle and complex. We have moved from the search for a needle in a haystack to the search for a single anomalous piece of hay. The silence of the radio waves was a clear, unambiguous null result. The atmospheric data from JWST will be anything but. It will be a flood of complex, noisy, and deeply puzzling information. It will likely give us more questions than answers. It will show us a zoo of new planetary types, a host of atmospheric compositions that will challenge our theories. And somewhere in all that noise there might be a signal, the faint, persistent, and beautifully ambiguous ghost of a distant biosphere. The challenge will be in knowing it when we see it, and in convincing ourselves that it is real. The hunt is on, not for a voice, but for a breath. And the first signs are that the universe is filled with a surprising and wonderful variety of air to sniff. The James Webb Space Telescope is not just looking at one or two worlds. It is designed to be a survey instrument, a machine for building a catalogue of cosmic atmospheres. Over the course of its mission, it will observe hundreds, perhaps even 1,000 exoplanets. This is where the hunt for biosignatures transforms from a series of individual case studies into a powerful statistical experiment. We will be able to perform a cosmic census to take a representative sample of the atmospheres of rocky planets in our local stellar neighborhood. This is a profound shift in our capabilities. For the first time, we can begin to answer not just, is there life on this specific planet, but the much broader question, how common is life in the galaxy? This is the true heart of the Fermi 2.0 paradigm. We are moving from a search for a single loud exception to a search for a statistical norm. Let us imagine the possible outcomes of this census. In one scenario, after a decade of observation, JWST has found nothing. It has analyzed the atmospheres of hundreds of potentially habitable worlds, and every single one of them is consistent with a sterile, abiotic equilibrium. The worlds with water are devoid of oxygen. The worlds with carbon dioxide show no signs of methane. The chemical fingerprints are all without exception those of dead worlds. This would be a profound and deeply sobering result. It would be a new kind of great silence, a silence not of radio waves but of chemistry. It would suggest that the galaxy is not teeming with silent, living worlds. It would imply that the transition from a habitable planet to an inhabited one is an incredibly rare event. The great filter, the hypothetical barrier that prevents the emergence of intelligent life, might be located at the very beginning of the story. The filter might be life itself. Abiogenesis, the process by which life arises from non-living matter, could be the single most difficult step in the entire cosmic evolutionary chain. In this universe, we would be a miracle of near impossible probability. Our loneliness would be a fundamental feature of the cosmos. The silence of the atmospheres would be a confirmation of our own profound and terrifying uniqueness. Now consider a different outcome. After a decade of scanning, JWST has found dozens of worlds with tantalizing hints of disequilibrium. We find a handful of planets with significant oxygen but no methane. We find a few more with methane but no oxygen. We find a number of worlds with strange combinations of other gases like sulfur compounds and nitric oxides that are difficult to explain with our current geological models. The universe would be revealed to be a place of complex and diverse atmospheric chemistry, a zoo of planetary possibilities, but there would be no smoking gun, no world with the clear, unambiguous oxygen-methane-water signature we are looking for. In this scenario, the hunt for life would remain in a state of tantalizing ambiguity. We would have a long list of candidate worlds, each one a mystery to be solved. The silence would not be absolute, but it would be deeply confusing. We would have found a host of chemical ghosts, but we would not know if they were the ghosts of biology or simply the ghosts of our own incomplete understanding of planetary science. This would be a universe that is perpetually on the cusp of revelation, a place where the evidence for life is always just beyond our grasp. It would be a form of cosmic purgatory, a state of permanent, hopeful uncertainty. Finally, let us imagine the most dramatic and perhaps the most hoped-for outcome. JWST finds a world, not just a hint, but a clear, robust and persistent signal. A rocky Earth-sized planet in the habitable zone of a nearby star with an atmosphere that is rich in water, oxygen and methane. The signal is confirmed with multiple observations. The data is scrutinized by the entire scientific community. Every known abiotic mechanism for producing this atmospheric composition is ruled out. The conclusion, though reached with extreme caution, becomes inescapable. We are looking at a planet with a powerful global biosphere. We have found life. This discovery would be the single most important in the history of science. It would be a definitive game changer. The Fermi Paradox would be resolved not because we found intelligence appear to talk to, but because we found life, a silent companion in the cosmos. The silence of the radio waves would be recontextualized. It would no longer be a sign of absence, but a sign that intelligence is rare. Life, however, would be common. We would be part of a vast galactic garden, even if we are the only ones in it who have learned to speak. This discovery would ignite a new golden age of astronomy. This living world would become the focus of all our observational efforts. We would study it with every telescope we could build. We would search for the seasonal variations in its atmospheric gases, the signs of a planetary scale metabolism. We would analyze the light reflected from its surface, looking for the red edge, a sharp change in reflectivity at a specific wavelength that on Earth is a telltale sign of vegetation. We would be able to map its continents and oceans to study its climate to build a complete holistic picture of a living, breathing alien world. It would be the birth of a new science, comparative exobiology. We would finally have a second data point, a way to understand our own planet and our own biology in a broader cosmic context. But JWST's hunt is not limited to biosignatures. It can also search for technosignatures, the signs of an industrial technological civilization. These would be a different class of chemical ghost. Instead of the byproducts of biology, we would be looking for the byproducts of industry. A civilization that burns fossil fuels, for example, would pump large amounts of carbon dioxide and nitrogen oxides into its atmosphere. A civilization that uses certain types of industrial processes might produce artificial compounds that do not occur in nature, such as chlorofluorocarbons or CFCs. These are powerful greenhouse gases, and on Earth their presence in the atmosphere was a direct result of our own industrial activity. JWST's instruments are sensitive enough to detect CFCs in the atmosphere of a planet like TRAPPIST-1e. Finding such a compound would be an almost unambiguous sign of technology. It would be the discovery not just of life, but of a civilization. It would be the answer to the original Fermi Paradox, found not with a radio telescope, but with a chemical sniffer. Another more speculative technosignature that JWST could search for is the heat of a planet-spanning city. An advanced civilization might construct vast, globe-encircling urban areas. These ecumenopolizes would generate a significant amount of waste heat. This would create an anomalous thermal signature, a planet that is warmer than it should be based on the amount of light it receives from its star. JWST, as a powerful infrared telescope, is a perfect instrument for detecting this kind of planetary fever. It could also look for the artificial light from these cities on the night side of the planet. This would be an incredibly difficult observation, a search for a faint artificial glow next to the overwhelming glare of the parent star. But it is not impossible. The hunt for techno-signatures with JWST is a long shot, but it is a shot worth taking. It reminds us that the line between a biosignature and a techno-signature can be a blurry one. A planet's atmosphere is a canvas upon which both life and intelligence can paint their portraits. The first round in the match between JWST and the Great Silence is now underway. The initial data is beautiful, complex, and filled with surprises. We are seeing exoplanet atmospheres with a clarity that was once the stuff of science fiction. We are finding clouds, hazes, and a diverse zoo of chemical compounds. So far, we have found no unambiguous signs of life. The game is still in its early stages. The silence for now holds, but the potential for a game-changing discovery is very real. Every time the telescope points at a new transiting world, there is a chance that the data will contain a signal that will change the course of human history. We are living in a privileged moment, a time when the answer to one of our oldest questions may be within our grasp. We have built an eye to see the breadth of other worlds. The question is no longer if we can look, but what we will see when we do. The scope of the hunt is also expanding beyond the traditional definition of a habitable planet. Our search has been intensely focused on finding Earth's twin, a rocky world in the habitable zone of a sun-like star. But life may be more creative than that. The moons of the gas giants in our own solar system, like Europa and Enceladus, are thought to have liquid water oceans beneath their icy shells. These oceans are kept warm not by the sun, but by the tidal forces of their parent planets. They are dark, sunless worlds, but they could be teeming with life that is powered by chemical energy from hydrothermal vents, just like the life in our own deep oceans. JWST can contribute to the search for life on these habitable moons in our own solar system by analyzing the plumes of water that erupt from their surfaces, and it can search for similar moons orbiting the gas giants we are discovering around other stars. The habitable zone may be much wider than we thought, and the most common abodes for life may not be planets at all, but their countless icy moons. Then there are the rogue worlds, the planets that have been ejected from their home systems and now wander cold and alone through the interstellar darkness. These orphan planets would seem to be the most inhospitable places imaginable, but a large rocky world with a thick hydrogen atmosphere could maintain a surface temperature warm enough for liquid water for billions of years, its heat provided by its own radioactive decay. Such a world would be a self-contained biosphere, a dark, lonely island of life in the galactic sea. JWST is a powerful tool for finding these rogue planets. It can detect their faint residual heat through a technique called gravitational microlensing. The discovery of a population of warm rogue worlds would dramatically expand the potential real estate for life in the galaxy. The hunt for biosignatures is forcing us to abandon our planetary chauvinism and to consider the vast unexplored territories of cosmic habitability. Life may not be where we have been looking for it. It may be hiding in the dark on a moon we cannot see, or on a world without a sun. The ghost we are hunting may prefer the shadows. The arrival of the JWST era represents a fundamental shift in the terms of the Fermi Paradox. The paradox was born in an age of radio, and it was defined by the logic of communication and expansion. It was a paradox of absence, the silence of a universe we expected to be loud. JWST has given us a new set of eyes that can see the subtle chemistry of life, not just the loud engineering of intelligence. The question it poses is not about absence, but about prevalence. The game is no longer a binary one of finding a signal or not. It is a statistical one of measuring the frequency of biospheres. Will this be a game changer? Yes, almost certainly. Regardless of what it finds, the results will transform our understanding of our place in the cosmos. A universe in which JWST finds hundreds of living worlds is a universe in which we are not alone in our biology, but perhaps alone in our technology. It would be a cosmos filled with silent gardens, a place where life is common but intelligence is rare. The great filter would be shifted from the origin of life to the origin of mind. This would be a universe of immense beauty and wonder, but also one of profound responsibility. If we are the only species that can think and build on a galactic scale, then the future of the cosmos is in a very real sense in our hands. A universe in which JWST finds nothing is in many ways a far more terrifying place. It is a universe in which we are a fluke, a statistical impossibility. The silence of the radio waves would be echoed by a deeper, more fundamental silence of the atoms. It would mean that the universe is not a garden, but a sterile, empty desert, and we are its sole fragile oasis. Our responsibility in such a universe would be even greater to survive, to endure, and to carry the precious, lonely flame of life out into the unending darkness. Either way, the game is changed. The stakes are raised. The silence is about to acquire a new and more profound meaning. The hunt with JWST is not just a search for aliens. It is a search for the context of our own existence. We are holding a mirror up to the cosmos, and we are about to see for the first time whether anything is looking back. The first definitive proof of a biosignature would be a moment of quiet scientific triumph, not a dramatic Hollywood reveal. It would be a conclusion reached after years of painstaking observation, data analysis, and intense debate. The evidence would be a series of spectral lines, a subtle statistical anomaly in the chemical makeup of an atmosphere dozens of light years away. There would be no picture, no sound, no message. There would only be the cold, hard, and beautiful data. The ghost would be captured not in a photograph, but in a graph. And yet the implications of this quiet discovery would be the loudest thing to ever happen to humanity. We would have found life. So then what? The first phase would be one of verification and characterization. The discovery would need to be confirmed by independent teams using different instruments. The world would learn a new word, exobiology. The planet in question would become the most famous object in the night sky. A single faint point of light that would hold the attention of the entire world. A new generation of telescopes would be designed and built with the sole purpose of studying this one precious world. We would dedicate centuries of scientific effort to understanding its seasons, its climate, its geography, and the nature of its biosphere. We would be like a botanist who has spent a lifetime studying a single blade of grass and has just been shown an entire alien rainforest. The work would have only just begun. The philosophical and cultural impact would be immediate and profound. The discovery would shatter the illusion of our own cosmic centrality once and for all. We would be forced to see ourselves as just one manifestation of a universal phenomenon. This would be a deeply humbling and perhaps deeply unifying experience. The divisions that seem so important on our own world, our nations, our religions, our ethnicities, would be cast in a new stark perspective. We are all Earthlings, the inhabitants of one of two known living worlds. This new cosmic consciousness could be a powerful force for good, a catalyst for a more mature and unified global society. It could be the moment that our species finally grows up. Religions around the world would be forced to grapple with the discovery. Some would see it as a confirmation of a creator's prolific handiwork. Others might see it as a challenge to theological frameworks that place humanity at the center of a divine plan. The discovery of life elsewhere would not necessarily disprove the existence of God, but it would certainly complicate the picture. It would be the beginning of a long and fascinating dialogue between science and faith, a conversation conducted in the new light of a second Genesis. But there would also be a darker side. The discovery could fuel new anxieties, new fears, and new ideologies. The alien life would be a blank screen onto which we would project our own hopes and terrors. Some would see it as a source of salvation, a repository of cosmic wisdom. Others would see it as a potential threat, a biological or existential contaminant. The planet would become a new kind of holy land, a source of new cults and new superstitions. The very distance and silence of the new life would be a breeding ground for myth and speculation. The ghost, by its very nature, would be easy to misinterpret. We would have to guard against our own tendency to fill the silence with the echoes of our own desires and fears. The discovery would also raise a new set of profound ethical questions. Do we have a responsibility to protect this new life, or do we have a right to study it, even if our study is invasive? The temptation to send a probe to get a closer look would be immense. But such an act would be fraught with peril. A probe from Earth could inadvertently contaminate the alien biosphere with our own hardy microbes, a form of interstellar plague. Conversely, a sample return mission could bring back alien microorganisms that could be devastating to our own ecosystem. The principle of planetary protection would have to be extended to an interstellar scale. We would be forced to confront our own role as potential cosmic custodians or potential cosmic vandals. The silence of the new world would be a powerful argument for a policy of non-interference. We would be the guardians of a secret garden we must never set foot in. Then there is the question of intelligence. The discovery of a biosphere would not answer the question of whether there is intelligent life out there. It would, however, change the probabilities. A galaxy filled with life is a galaxy where the chances for the evolution of intelligence are much higher. The discovery of a second living world would be a powerful incentive to redouble our efforts in the search for technosignatures. We would know that the raw material for intelligence is common. The silence of the radio waves would become even more puzzling. Why would a galaxy teeming with life be so quiet? It would strengthen the arguments for a great filter that lies between the emergence of life and the development of technology. We would have found the garden, but the gardeners would still be missing. This would be a new, more refined version of the Fermi Paradox, a Fermi 2.5. Let us consider the alternative. What if the hunt with JWST after decades continues the silence? What if we scan 1,000 worlds and find nothing? This, in its own way, would be just as profound a discovery. It would be the first strong empirical evidence that life is rare. The silence of the atmospheres would reinforce the silence of the radio waves. It would be a double confirmation of our solitude. This would be a heavy and perhaps a lonely burden to bear. It would mean that the spark of life on our own planet is an event of almost unimaginable preciousness. We would be the sole custodians of a phenomenon that is, for all we know, unique in the observable universe. This realization could be a powerful catalyst for a new kind of global ethic. If life is this rare, then our own biosphere is not just a planetary resource, it is a cosmic treasure of infinite value. The ongoing extinction crisis would be seen not just as an environmental problem, but as an act of cosmic vandalism. The preservation of life on Earth would become our most sacred duty. The silence of the universe would be a command to protect the only sound we know. Our loneliness would be a source not of despair, but of a profound and urgent sense of responsibility. We would be the keepers of the only flame in a vast, dark and cold universe. We would have to ensure that we do not let it go out. The hunt for biosignatures with JWST is a can't-lose proposition. Either we find life and our view of the universe is changed forever, or we do not, and our view of ourselves is changed forever. The game is already afoot. The data is already flowing. We are already living in the Fermi 2.0 era. We are the first generation of human beings to have the tools to look for the chemical ghosts of other worlds. We are the ones who will have to live with the consequences of what we find or what we fail to find. The silence of the past has been a silence of ignorance. The silence of the future will be a silence of knowledge. The next few years will be a time of intense discovery and perhaps profound disappointment. We will see the atmospheres of dozens of new worlds. We will find water, methane, carbon dioxide. We will find clouds of silicate dust and skies of yellow haze. We will build a beautiful, complex, and wonderfully detailed picture of the diversity of planets in our galaxy. And somewhere in that picture there may be an anomaly, a single data point that does not fit, a world that is breathing. If that day comes, it will not be the end of the story. It will be the beginning of a new one. It will be the moment that humanity, a species born on one small living world, finally realizes that it is part of a much larger and much stranger cosmic family. The first proof of a biosignature will be the universe's quiet chemical way of saying, "Welcome, you are not alone." And then the real work of figuring out what that means will begin.